Hello, everyone. Welcome to our presentation on the Flexure Lab. My name is Lucas Petra,
My name's Ethan Mitchell.
My name's Isaiah Oduro.
and today we'll walk through our experiment and the findings and analysis related to the flexure and strain measurement techniques. This experiment builds on our previous tensile lab by shifting focus from tension to bending. We were tasked to use strain gauges and a crosshead displacement to evaluate the stiffness, as well as calculate both the experimental data and the theoretical beam data analysis. First, we recorded the sample and the measurements. Then we recorded the 3-point load sample, including the displacement, the strain gauge, and voltage data with our phones, and we processed the data through Excel.
Okay. So using the data that we recorded on the phone, we were able to make three different graphs. The first graph that we made was directly from the force and displacement that was in the video. We used this data, just plotted force versus displacement, and with that we found the stiffness of the material. Using the stiffness of the material, we use the equation on screen in order to find the Young's modulus in PSI. Next, for stress and strain, um, it was a little bit more difficult to find the stress and strain compared to directly taking the force from the video. But for stress, we calculated it using the moment of the force around one of the rollers divided by the moment of inertia in order to find just the stress. And then the strain was found from the voltage, from the gauge, from the strain gauge and the voltage that we found using the equations. As you can see, there's a small diagram of the kind of layout of the where the moment arm was and how the moment was taken around one of the rollers. The Young's modulus that we found was 519,000 psi, which is within a 20% difference from the original or from the force versus displacement Young's modulus. Our flexure graph is essentially a visual representation of what the beam did during bending. This flexure graph shows the correct shape as it's like parabolic, and which is what we saw during the video. Next, for our results and analysis, we saw that all the graphs showed the expected shape. There were clear linear regions in the stress strain and force displacement graphs, as well as a parabolic shape in the flexure graph, which is nearly exactly what we saw um, during lab. Lastly, we compared our data with data from another group. We found that our Young's moduli, or at least our Young's moduli found from load and displacement, was closer or was very close to the other group with only around an 11.4% difference. Um, this also showed us that the correct Young's moduli for the material was likely around 400,000 psi. Um, our stress strain Young's modulus was around 30% higher than the other groups, which shows that we most likely had a calculation mistake as the low displacement Young's modulus was rather accurate. Um, yeah.
And then for this lab, we were able to compare experimental measurements of beam bending with theoretical predictions. Force displacement and stress strain data both showed clear linear regions, which allowed us to calculate the Young's modulus using two different methods, one from the low displacement curve and the other from the strain gauge data. Both values were reasonably close to each other and to reference values, indicating that our measurements were accurate and that the strain gauges were properly bonded. The flexure graph demonstrated the characteristic beam curvature, with maximum displacement at midspan consistent with three-point bending theory. Small deviations from theory were likely due to experimental uncertainties such as slight misalignment in loading, bonding inconsistencies with the strain gauge, or minor noise in voltage measurements. Overall, the lab confirmed that strain gauges provide precise strain measurements, and combining these with load and displacement data gives a reliable way to evaluate bending stiffness in beams. Due to the percent error, it could be due to slight hand measurement errors in the lab or hand calculation errors in the lab. This is due to several iterations of fixing calculation mistakes. In conclusion for this lab, it successfully demonstrated how beam bending behavior can be measured and analyzed both using strain gauges and displacement data. We were able to calculate the Young's modulus from two independent methods and found good agreement with theoretical predictions, validating the experimental setup. The flexure measurements confirmed the expected beam shape under a three-point bend, and the results highlighted the importance of accurate strain measurement and careful experimental technique. Overall, this experiment reinforced the connection between theory and practice in material testing, showing how strain, stress, and bending stiffness can be quantified and compared to predictions. For some future work for this experiment, we could recommend optimizing the strain gauge placement to reduce inaccuracies in the tests, and exploring different materials or beam designs could also provide further insights. Advanced techniques like digital image correlation could also enhance the strain measurement precision. And then for this experiment, these are our references that we use throughout this experiment to get our data. And thank you for watching our video.